Sine of the 285 degrees minus sine of 15 degrees. So first, let's write out the sum to product identity which we will use in this problem. So this is of the form sine of the x minus sine y. Right, we have the sine x minus sine y equal to 2 times cosine of x plus y over 2 and times sine of the x minus y over 2. So now this x is just equal to 285 degrees and y is equal to 15 degrees. So let's plug in them into this right side. So you have the 2 times cosine of the 285 degrees plus 15 degrees over 2 and then times sine of the 285 degrees minus the 15 degrees over 2. Then you simplify. So 285 plus 15 have the 300. 300 over 2 you have the 150. So you have the cosine of the 150 degrees times sine. So 285 minus 15 you have 270. 270 over 2 you have the 135. So sine of the 135 degrees. Now tell me what is the reference angle of 150 degrees? 30, right? You have the 180s minus the 150, so you have 30, so 30 degrees. And what is the sine of the cosine 150 degrees? Negative, positive? Negative, right? In the quotient 2 is negative. So this guy. So this is 150 degrees. So in the quotient 2, cosine is negative. So you have the negative 2 times cosine 30 degrees. And then what is the reference angle of 135 degrees? 45, right? 180 minus 135, you have the 45. And sine is positive in the quotient 2. So sine of the 135 degrees is equal to sine of the 45 degrees. And then you know the value for these two cosine and sine of the spatial angles. So this is equal to negative 2 times root of 3 over 2 and times root of 2 over 2, right? So you cancel this 2 and this 2, and then you get negative root of 3 times root of 2, root of 6 over 2. Then done. Now let's look at one more problem. Let's look at the problem 54. And in this 54, we need to verify such an identity. So cosine 5y plus cosine 3y over cosine 5y minus cosine 3y equal to negative cotangent 4y times cotangent y. tell me which side should I begin with? Left, right? Because left side is more complicated. So we begin with the more complicated side. So L, this guy, is equal to, and for the numerator denominator of this left side, we need to use the sum to product identities. So for this one, we know this is equal to 2 times cosine of the A plus B over 2, n times cosine of the A minus B over 2, right? So by the sum to product identity, so we have the 2 times cosine of A 5y plus B 3y over 2, and then times cosine of A 5y B 3y, okay, over 2. And for this one, we need to use identity, okay, sum to product identity. That is the cosine of the A minus the cosine of the B equal to negative 2 times sine of A plus B over 2 and the sine of the A minus B over 2. Okay, this guy, identity 8, cosine of x minus the cosine y equal to negative 2 times the sine of the half x plus y and half x minus y. So this denominator is equal to negative 2 times sine of 5y plus 3y over 2 and times sine of 5y minus 3y over 2. Now let's continue to simplify. Let me write here. So this 2 and this 2 cancel, right? And then you have this guy 5y plus 3y, you have 8y. And 8y over 2, you have the 4y. So cosine 4y and 5y minus 3y, you have 2y. 2y over 2, you have y. So cosine y. And similarly, you have the negative sine 4y and the sine y, right? And then let's move to here. You have the cosine 4y over the sine 4y. You got the cotangent 4y. So negative cotangent 4y. And cosine y over the sine y. Then you got cotangent y. So this is just the right hand side. And in this way, we verify this identity. So the sum to product identity and the product to sum identities look complicated, but actually when we try to apply them, it's very simple, right? So no big deal.